Hello everyone, this is Mr. William and today's lesson is going to be on scatter plots. Let's get started. Our objective is to be able to use scatter plots to compare data. One of the first things you need to know is that the letters or the prefix bi means two. So a bicycle has two wheels. One, two. Bifocal means you can see two distances. You can see close, you can see far away. The word bi means two. All right, so bivariate means you have two variables. So let's look at this table here. What are my two variables in the table? My two variables in the table are season and viewers. Season and viewer. This person here is viewing, is a TV viewer. They're watching TV. All right, what are my two variables in the next graph? Well, we have memory, measured in gigabytes, and then you have cost. So as your memory goes up, the cost goes up. Okay. What are my two variables? Remember, bi means two, so bivariate means there's two variables. What are my two variables in this one? Well, it's time in minutes and temperature in Celsius. Okay. What are my two variables here? Well, I have on my x-axis I have days, and I have number of liters sold. Okay, so bivariate means I have two variables. I have my x days, I have my y number of liters sold, I have my x time, and I have my y temperature. All right, so let's graph the data from the table. Don't forget to label the x and y axis. So weeks is our x and weight is our y. Why? Because I know that over time, your weeks change, your weight changes. So weight depends on weeks. The weight depends on weeks. So we're going to put weight here. And we're going to put weeks here. 0 weeks, 3 kilograms. 9 weeks is about right here, 4 3/10. 18 weeks is 5. Now, one thing about a scatter plot is that it doesn't have to be in a straight line. It just is what it is. 27 is 6 8/10. That's about right here. 34 is 7 1/2. 34 is about right here. 43 weeks is 8 6/10. It's about a pair. And 49 is 9. Is really close to 10. So 49 is really close to 10. All right. Again, we're not looking for a straight line. We just want to label it. So here is my independent variable, weeks, and my dependent variable. Weight. Okay. All right, here's another one. Let's graph this one. The units produced. So unit is just something. It could be cars, it could be pencils, it could be erasers, it could be pens. Produced is what you make. Okay. So units produced have cars here. And my units produced depends on time. So that's my Y and that's my X. So time or hours. And I'm going to write it this way. Units produced. All right. So in 8 hours, they make 19 units. It's about right here. And in 41 hours, they make, in 19 hours, they make 41. In 16 hours, they make 40. In 40 hours, they make 60. In 34 hours, they make 49. In 8 hours, they make 28. That's about right here. In 40 hours, they made 63. In 19 hours, they make 40. And in 34 hours, they made 58. So you can see, sometimes in the same amount of hours, they made more. So in 34 hours, one time they made 58, another time they made 49. One time they made 19. In 19 hours, they made 41. Next time, they only made 40. One time, in 8 hours, they made 20. And another time, they made 28. So it's not a straight line. All right. So scatter plots show the association between bivariate data. Remember, bi means two. Variant means variable. Bivariate data basically means an X and a Y. All right, so I can have a positive association. That means as my X goes up, my Y goes up. I can have a negative association. When my Y goes up, my X goes down. Or I can have no pattern or no association. If my X goes up, I don't know if my Y is going to go up or down or stay the same. You also have a linear association where it looks like a line. And you have a curve, a nonlinear, where it looks like kind of a curve. Okay? So that's your associations. Positive is by variable, positive, negative, and no association, or whether it's linear or nonlinear. So you can go positive goes up to the right, negative goes down, no association, no particular pattern. It can look like a line or look like a curve. Those are your different associations. All right, so interpret means to make sense of something or to give it meaning. So you think of an interpreter is somebody who helps people make meaning of different languages. All right, we're going to ignore this right now. All right, so we want to interpret the scatter plot of data for the time elapsed and temperature. So I have time elapsed on the x-axis, temperature on the y-axis. So we're going to use dissociations. Is it positive, negative? Is it linear? Or is it curved? So it's pretty linear. It's almost a straight line. Not exactly a straight line. And is it positive or negative? Or is it no association? It's negative. All right. So it's linear and it's negative. We could have said negative linear. Doesn't matter. Okay. The next one. Interpret this scatter plot. It's pretty linear, right? But this one, it kind of goes up, so we say it's positive. Okay? So go ahead and interpret these scatter plots. Let me know if it's positive, negative, linear, association, or no association.